So part 3 of 3, we are finally ready to close both gaps, recessionary and inflationary, by using one of our fiscal policy tools, changing government spending levels, changing taxes, or changing transfers. And we're starting this off with what is known as the multiplier effect. I alluded in the first video to the idea that we might overshoot our target. Recall that I said if we have, say, a $200 billion recession where we need to add $200 billion worth of GDP to the economy, if we change government spending by $200 billion, we're going to get more than $200 billion worth of increase in GDP. Doesn't necessarily make sense right at the outset, but this is what is known as the multiplier effect. So if we cut taxes by $200 billion, we're going to get more than $200 billion in GDP. And we don't want to overshoot the target because then we get inflation without any improvements in unemployment. You're not helping anybody, you're just hurting people when that happens. And if we're trying to reduce inflation by raising taxes, cutting spending, etc., obviously, we don't want to overshoot the target in that case where we're trying to decrease GDP because we'll decrease it so much that we'll have higher unemployment because of the multiplier effect, the concept that an additional dollar of expenditures will result in the creation of more than $1 worth of real GDP. So recall that we are looking to close recessionary and inflationary gaps. Recessionary gap, I've been referring to it a few times, but I thought it was useful to have a slide here to remind ourselves that that's the difference between where GDP is now and where we want it to be. Same thing with an inflationary gap. It's just on the other side, the difference between where GDP is now and where we want it to be. Where it is now with an inflationary gap is somewhere where all we're seeing is higher prices with no benefit coming in the form of lower unemployment. So, to close these gaps, we want to use fiscal policy, but we have to be wary of the multiplier effect. We don't want to overshoot the target. Why would we overshoot the target, though? Where does this multiplier effect come from? Well, something you may hear a lot when you hear economists speak is that my spending is your income and your income is my spending. In other words, when one person receives income, they spend a portion of it, and whoever gets whatever they spent, well, that's going to become their income. So government purchases increase to try to close a recessionary gap. New government workers are hired and they're paid a wage. Well, those new employees are going to go and spend that wage in the economy, and they're going to buy something that the owner of the business is going to see as income coming in. People are buying whatever they're selling, so their income goes up. The owner of the business, their income goes up. Or maybe they have to hire more employees whose incomes go up. And they're going to go and spend in the marketplace. And another increase in income is going to happen, and so on and so forth. And this just keeps on going and going and going. Now, it seems like this should go on all the way to infinity. But it doesn't. And the reason it doesn't is because, remember, we don't spend all of our income. We do save some of it. Remember, we're living here in the short run. So extra income is spent, but some of it is saved. So at each stage, as somebody's spending because somebody becomes somebody else's income, which becomes somebody else's spending, each stage in that process, some money is being taken out of the short-run economy and held in the form of savings. So less is being spent at every stage, and that decrease in spending just keeps going down until we're talking about pennies, and then all additional pennies are just thrown into a jar and we're done. So the multiplier, I mean, you can work this through if you want, a $200 billion increase in spending. Some of it's saved, some of it is spended, some of it is saved at the next stage, and then some of that is spent. And you can work that through over the course of dozens to hundreds to thousands of transactions if you want, and then add it all up. But I don't know about you, I wouldn't want to do that. I'd want to make things a little bit easier. And fortunately, we have a multiplier that makes it easier. The equation for the multiplier, we're not going to go into how this is derived. You have an infinite series basically, and it all converges to this. 1 divided by 1 minus marginal propensity to consume. This is the multiplier. This subscript E here means that it's the expenditure multiplier. We're distinguishing it from other multipliers. We'll get to the other one in a second here, but it's because we have a different equation. It operates differently. Right now, we're only talking about changes in government spending, and now we're finally going to see why transfers operate in a different way and why they're separated out from government spending. But right now, we're just talking about spending. Government purchases. Government actually buys something, goes into a market, a labor market with government employees, or some other goods market to buy raw materials to do whatever it is that the government's doing. We're using a spending multiplier there. So why are we using marginal propensity to consume? Well, because once again, this process plays out until all the additional money that's being turned from spending to income and back again has been saved and is out of the economy. At each stage, the amount of extra spending goes down because money is saved. How much is saved? Well, the MPC tells us exactly how much is saved. What percentage of that money at each stage is going to be held out in savings. 1 divided by 1 minus the MPC is going to give us the multiplier. One thing before we get to an example that you might notice, 1 minus the MPC, what does that equal to? I mentioned in the first video that we have an equation, MPC plus MPS equals 1. So 1 minus MPC algebraically is MPS. So this can be rewritten as 1 over MPS. And sometimes it might be handy to do that. You're given an MPS but not an MPC. Well, you're fine. Just go 1 over MPS and you get the spending multiplier. But because we're using marginal propensity to consume, because we're looking at the amount of money that's spent, we tend to use this equation, at least for starters. So for an example, if the marginal propensity to consume is 0.6, which means if you make $100, you're going to spend 60 of it, and then 40 is going to go into savings. So if 0.6 is the MPC, the spending multiplier is 1 divided by 1 minus 0.6, which is 1 over 0.4, which is 2.5. What do we do with this multiplier? Well, whatever change in expenditures that we have, government purchases here, that $200 billion, for example, we're going to have to multiply that by the multiplier we just got here, 2.5, to get what would turn out to be $500 billion would be our change in GDP. 200 billion here, 2.5. If 0.6 is our MPC, we're going to overshoot the target by a total of $300 billion and get some inflation that isn't going to help us lower unemployment anymore. We got the 200 billion we needed to lower unemployment. We got an additional 300 billion that just gave us inflation and nothing but. We overshot the target, and so we would want to have spent it less. How much less? Well, we can use the multiplier to solve that problem too. You take that $200 billion gap we want to close, divide it by the multiplier, and you're going to get a smaller number, and that smaller number is going to be equal to the number of expenditures that we want. So 200 billion divided by 2.5 is going to give us 80. So we want to put 80 billion here, multiply it by 2.5, and we would get 200 billion. As an example, using the numbers that we've been working with here. So I mentioned that the tax and transfer, this is just the tax multiplier, but you can easily substitute in transfers. It operates the same way. We have a different multiplier here. So why do we have a different multiplier? Well, what this tells us is how much a change in taxes or transfers is going to get us. Your consumption will decrease when you're taxed, but not by the full amount of the tax. Again, there's going to be some savings there. The reason we have a different equation for the tax multiplier, and this is what the equation is, we'll get into why it's this way in a second, It's because with government spending, that money's going into a market right away. That the first transaction is the first thing that happens to the money. Government purchases increased by 200 billion, or we just found out we want it to be 80 billion if our MPC is 0.6. That's $80 billion that goes into a market, and it's already in the economy. Nothing was saved. The entire 80 billion goes in. But if we transfer that money, then that money is going to go from the government treasury to somebody else if it's $80 billion worth of a transfer, and people are going to save some of it. They're not going to spend the whole thing. If it's a tax cut, then your disposable income went up, but you're not going to spend that entire income. You're going to save some of it. So you have to multiply it by the marginal propensity to consume first before you can use the spending multiplier. Notice that this is 1 over 1 minus MPC multiplied again by marginal propensity to consume. MPC over 1 minus MPC gives you the tax and transfer multiplier. Alternatively, you can write it MPC over MPS is the tax or transfer multiplier. But we have this minus sign here. This is what makes it specifically the tax multiplier. This is saying that if taxes go down, then spending or GDP is going to go up. They're going to go in the opposite direction. So your multiplier has to take that into account. If you have a tax cut of 80, taxes went down by 80, you want spending to go in the opposite direction. You want GDP to go up if taxes go down. So this minus sign right here does that for us. If you have an inflationary gap and taxes are increased, taxes went up, but GDP is going to go down. Again, that's why we have this minus sign here. So as an example, again with an MPC of 0.6, we have minus 0.6 up here, divided by 1 minus 0.6 down here. And this is rewriting it as MPS, minus 0.6, or the opposite of the marginal propensity to consume, divided by marginal propensity to save, gives us a tax multiplier of 1.5. Notice our MPC is the same here. We're working with a 0.6 MPC, which got us a multiplier of 2.5 for the savings multiplier. But here, it's getting us a tax multiplier of 1.5. The tax and transfer multiplier is always smaller than the savings multiplier because, again, the money that gets shifted around that is taken away from government revenues, if it's a tax cut, it's taken away from whatever government has in the treasury, if it's a transfer, that amount of money, some of it will be saved, so it's going to have a smaller multiplying effect. This is one of the reasons why spending is going to be one of the fiscal policy tools of choice instead of taxes and transfers, because spending is going to give you the bigger multiplier. You don't have to have as large of a deficit impact. You can spend a little less and get the same thing as you would with a larger tax cut or a larger transfer. Tax cuts and transfers are desirable as well, though, because tax cuts have you're basically letting people hang on to more of their own money. You're not putting any artificial money in the system, so it doesn't have the inflationary effects that you would get from the equation of exchange. And of course, transfers allow you to target people who need money the most if you're looking to stimulate the economy, or who need money the least if you're looking to draw it back. So you can target things a little bit better with transfers and just directly give cash to people who need it, let them spend it as they want. So those are some of the arguments for each of the 3 different fiscal policies. And altogether, these 3 videos give us everything we need to know about the aggregate expenditure model.